Okay, so now we're on the back side of your notes, guys, the next page. So Stephen plans on increasing the amount of money in his savings account by 30% each year. He currently has $600 in his savings account. How much money is he going to have in 4 years? So setting myself up, he starts with 600. He wants to know how much he's going to have in 4 years. So then in the center, I need to go 1 plus that 30%, which is 0.3. So I go to a calculator, I plug and I chug. So I got 600, 1.3 raised to the fourth. And you get $713.66. So I get $1,700 $1,713.66. This next one right here, we'll come back and do that together live with me. This one, the following occasion represents the value of a car after 2 years. So if you notice, our B value is less than 1. So we are what? Decreasing, because that depreciates. Cars depreciate. What is the percent rate of change for the value of the car? So here's the thing. B is less than 1. But here's the thing. I know 1 minus R should equal my B value, which is at 0.85. So 1 minus R will get me to that. So I go 1 minus R is equal to 0.85. So when I come over here and look at my answers, 85% doesn't look right. 1.5, these other ones look okay. So when I go like this, 1 minus 0.85 should be equal to my R value. So R is equal to 0.15%. So there we go. Next one. A single-celled organism divides into two once per day. So I start with 1 cell, and then it's going to split down the middle. So then I'm going to have 2 cells, and then those are going to split, and then I'll have 4 cells, right? If you have one of these organisms at the start, write an equation for the number of cells you'll have at the end of the day. So you guys, this is just like our piece of paper task where I folded. So we start at 1, then we go to 2, and then we're going to go 4, and then we're going to go to 8. So then after 3 days, if I put n is equal to 3, I know I should have 8. Well, if I plug in this right there, 2 times 3, does that give me 8? No! 3, if I plug in here, 3 squared gives me 9. So does that work? No! 2n squared. So that's 9 times 2. That's going to give me 18. That doesn't work. So if I plug in this, 2 to the third, does that equal 8? Yes. Same thing. Okay, on this one. James opens a savings account with X dollars that earn 15% interest per year. Okay, after 15 years, James decides he wants to withdraw 15% of the total. This is the expression. So this is just my original thing. This is what's going to happen. So we go 1 plus 0.15 is to the 15, and this is times by X, right? So just talking about this, that's before he's going to withdraw this 15%, which is what he's going to withdraw after 15 years. Which part of the expression describes the interest? So what I know right now is this. It's not this exponent of 15, because that is the exponent of 15. That is my time. It's not the factor of this 0.15 out front. That's the amount withdraw. Right? The factor of 1.15 or the factor of X. X right here, right? X is our initial amount. And then right here, 1.15. Here's the thing, guys. 1 plus 1.15, that's the part that represents the what? Interest. My next thing on this one, which of the following functions represent exponential growth? So I know this, b has to be bigger than 1. The b down there is 1/3, 1/2. It can't be those two, so I'm left with these two options. I need to remember when I have a negative exponent, that means to make it positive, it goes to the bottom. Oh, that's going to mean it's less than 1. That's the only one that has a b value bigger than 1. Our next one, when money is invested, the new account M is calculated based on the original amount invested A over a period of time T and an interest rate. Which equation demonstrates by its structure that the interest rate R is added to the whole, then calculating the balance into the account? So added to the whole. I start at what? Added to the whole means I start at 100%, then I get interest. Okay, so if I go back to the equations that I know, A is equal to my initial amount, which is my little a, 1 plus my interest rate to the t. So if I look over this, rate plus time doesn't make sense. I don't have a 1 value in that one. It's just rate to the time. This one doesn't make sense because I'm doing my initial amount plus 1. That doesn't make sense. This one is the only one that shows you that you start at 100% because that's what the 1 represents, is 100%. So the answer is C. So on the next one, an expression is shown here where y, x, and n are positive integers. What happens to the value expression when, and I know you guys have this in your notes, y is doubled? So what happens when I just go and I times y by 2? The only thing that's going to change is our original values multiplied by what? 2. Doesn't change anything else on the outside. It doesn't change this stuff at all. Just changes that by 2. Last but not least, when this exponential function, 400 times 2 raised to the 0.3x, when is that closest to what? 60,000. So the way to make sure I know what's going on there is to go 400 times 2 to the 0.3x. I need to go look at this in a table and then see when it's closest to 60, if it's at around 7, 16, 21, or 24. So I'm coming back to my table. So I come here, y equals, clearing it out, typing in 400 times 2 raised to the 0.3x. Second table. Ooh, starting at 0. At 10, I get 3,200. So I know it's not our 7 value. So then I keep going. My next value is at 16. So at 16, I have 11,000. That's not 60,000. So our next one I want to check is around 21 to 22. 21 to 22. At 21, I'm at 30,000 in that range. So it's not that one. So let's keep going. 23, 24, 24. I'm really close to 60,000. At 25, I'm past 60,000. So here's the thing. The answer then is 24.1. Check, check.